Why one side of the Earth is rapidly getting colder than the other. A strange tale of two hemispheres. New research shows the Pacific Hemisphere is losing heat faster than the African Hemisphere. The heat is from Earth's molten interior, which causes continental drift. Landmass traps more heat than seafloor surface, indicating a hotter Pacific of the past. In a new study, scientists from the University of Oslo say one side of Earth's interior is losing heat much faster than the other side, and the culprit is practically as old as time. The research, published in Geophysical Research Letters, uses computer models of the last 400 million years to calculate how insulated each hemisphere was by continental mass, which is a key quality that holds heat inside instead of releasing it. The pattern goes all the way back to Pangaea. Earth has a red-hot liquid interior that warms the entire planet from inside. It spins, too, generating both gravity and Earth's magnetic field. This holds our protective atmosphere close to Earth's surface. Over the extremely long term, this interior will continue to cool until Earth is more like Mars. The surprise in the new study is how unevenly the heat is dissipating, but the reason makes intuitive sense. Parts of Earth have been insulated by more landmass, creating something of a thermos layer that traps heat. This contrasts with how Earth loses most of its heat. Earth's thermal evolution is largely controlled by the rate of heat loss through the oceanic lithosphere, the study authors write. Why is this the side of the greatest loss? For that, we need a quick and dirty run-through of continental drift. Earth's mantle is like a convection oven that powers a treadmill. Every day, seafloor surface moves a tiny bit. New seafloor is born from the magma that erupts at the continental divide, while old seafloor is smashed and melted beneath existing continental landmass. To study how Earth's interior heat behaves, the scientists built a model that divides Earth into African and Pacific hemispheres, then divides Earth's entire surface into a grid by half degrees latitude and longitude. The scientists combined several previous models for things like seafloor age and continental positions during the last 400 million years. Then, the team crunched the numbers for how much heat each grid cell contains over its long life. This paved the way to calculate the rate of cooling overall, where the researchers found the Pacific side has cooled much faster. The seafloor is far thinner than the bulky landmass, and temperature from within Earth is quenched by the enormous volume of cold water that's above it. Think of the gigantic Pacific Ocean compared with the opposite side landmasses of Africa, Europe, and Asia. It makes sense that heat dissipates more quickly from the biggest seafloor in the world. Previous research on this seafloor effect only went back 230 million years, meaning the new model, which goes back 400 million years, almost doubles the time frame being studied. This data was taken from the link in the description. For more, you can click the link. If you like this video, give it a thumbs up. If you don't, well, still give it a thumbs up. And subscribe to my channel, it helps. Thank you for watching.